Hello, calculus. A lot of you still have questions about how to sketch the graph of the derivative given the graph of the function. So I thought I would do exercise 65 from your homework to see if I can help you out with that. So here's the graph of a function f of x, and we're going to try to graph the derivative. And I think the main thing to remember here is that the derivative is the rate of change. It's the slope. So we're going to figure out a few things about the slope, and that's going to help us graph it. Okay, so let's take a look at this function, and I'm going to sketch some things on top of it to help us understand the slope. So we want to look at some critical points here. I know that at this point right here, that's our tangent line. And that tangent line there has a slope of 0. So that means at this point of the function, my derivative should equal 0. And let's go ahead and put stuff that we know for sure about the derivative in red. So at x is equal to 3, I know that derivative is equal to 0. So that's why I put a red dot right on the x-axis, because it's going to be equal to 0. Now what's happening in our function to the right of this point? Well, this is I made it blue. I meant to do black. This is a slope that is increasing and positive. So it means that after 3, our slope must be positive. And before I get to 3, this is a slope that is decreasing and negative. So that means that to the left of 3, my slope must be negative. So here I already know I've got a slope that's positive to the right of 3 and a slope that's negative to the left of 3. Does that change at any point? Let's keep going to the left of 3. And I see here's another point where my tangent line looks really flat. If I drew a tangent line here, that tangent line would be really flat and have a slope of 0. So that means that right here, on the y-axis, I know that my tangent should have a slope of 0. If it's equal to 0, it's got to be right on that x-axis. And then, what's happening to the left of this point? What's happening to the left of where that is equal to 0? Well, look at the tangent line here. That's another decreasing tangent line. So the slope to the left of this point is negative. So now let's look at all the stuff we have in red and see if that helps us out. It looks like I have a negative slope all the way from negative infinity up until I hit 3, and then it becomes positive. And I have 2 places where my slope is actually exactly equal to 0. And there when x is equal to 0 and when x is equal to 3, my slope is exactly equal to 0. So if my slope is positive, and increasing here, then my slope is negative, scoops back up here. And that would be a good enough sketch of this derivative. So I hope that helps a little bit. Notice I didn't go crazy trying to make my derivative super accurate. I just said, where is this derivative going to be positive? Where is it going to be negative? Where is it going to be 0? And those are really the only 3 things you have to answer.